Today we're going to be talking about controlling beer haze. I think it's a very, very popular, maybe not popular, but a very, very important and hot topic because I can't tell you how many times I've heard from brewers um, who are having problems keeping their clear beers clear and keeping their hazy beers hazy, right? Last thing you want is for your Pilsner to be super hazy and your hazy IPA to be crystal clear, right? So, and unfortunately, it does happen. There's a lot of factors. It's a little bit complex, but what we're going to try to do here is we're going to look under the hood, help you walk away with a little bit more knowledge and information for beer haze. We are going to do a little bit of an extra deep dive into yeast's role in beer haze as well, because there's a lot of really cool recent research that's been coming out on this topic that helps us understand it better. And there's new yeast strains coming out, leveraging some of this information as well. Alrighty. Okay, so what are we going to talk about today? We're going to talk about what is haze. What do we mean when we talk about haze? We're also going to make sure that we mention haze and hazy IPAs. It usually isn't yeast. I think that is a preconceived notion that is starting to go away, but I still hear it every so often. I hear, people talk about using low flocculating yeast to make hazy. You do not need to. There are flocculant yeasts out there that are haze positive, and we'll get into that. What contributes to beer haze? It's obviously not just yeast. It's all sorts of different things. What do we know about how haze is formed? What are some of the unknowns out there that do need to be addressed as we, enter some of these new realms of beer? Hazy beer being popular is a very, very recent thing. So, it's taken some time for the science and the industry to sort of catch up to that. We're going to talk about specific ingredient impacts on haze. So that does include water, malt, and hops, and help you get a better understanding of that. And then we are going to dig in more into yeast's role in haze, including, what makes a yeast haze positive or haze neutral, and what does that even mean? And then we're also going to talk a little bit about controlling haze. One of the options you have for that is finings, or what we call fining agents. So we'll dive into that as well. Okay. So what is haze? We're going to try to keep it simple. Haze is any microscopic particle that's in your beer. So any type of microscopic particle, could be protein, could be yeast, that scatters light and creates a hazy appearance. That's what's going on with haze. You have particles that are inside that liquid that light is bouncing off, so the light cannot pass through the beer. And what happens is that creates what looks to us like haze, right? Light is bouncing off those particles. It's not transmitting through that beer, and it appears to us as haze. And the number and size of those particles will determine the intensity as well as the type of haze. So a similar way to think about this would be fog or smoke in the air. If you're outside on a really foggy day, that's because there's a bunch of water particles in the air. And that is diffracting light, scattering light, and making it harder to see. It reduces your visibility. So, that fog on a cold morning is quite similar to the haze in your beer. You have particles that are impacting the ability of light to be transmitted. And so when we're talking about haze, we're also talking about turbidity, right? It's how much can we see through that product. And we can also think of turbidity on a scale of water to milk. I really like this illustration. And I just also threw in some of the things that we might be targeting here. So in a hazy IPA, it can actually be quite turbid. As we know, it can be, even beyond orange juice in terms of turbidity. It can be almost milky or almost like skim milk. And that's in that, 1,000 NTU range, which NTU is turbidity units. It's a measure of overall turbidity. And you can use a device to measure NTU. So some of the larger breweries out there will actually have turbidity meters that can measure NTU, and they may even measure it at different angles of scattering to get a more specific measurement of haze. And on the other end of the spectrum, if we're looking to make a clear beer, usually what we're talking about is quite low turbidity, 50 NTU or lower. So what types of haze are out there? Number one, we'll talk about protein haze. So protein haze in beer does come from your malt. assuming you're using malt to make your beer, almost everyone is, you're going to extract some degree of proteins that could be haze positive. So typically what we know is that these are often what are called proline rich proteins. And there are some key examples. So barley has a protein called hordein that is proline rich and that can form haze that scatters light. Wheat has proteins called gliadins, which is sort of one half of what we call gluten. That is also a haze forming, haze potential protein. And in general, when we're looking at protein haze, smaller particles are the haze generating ones. If you have larger protein particles, those tend to just be physically too large and actually settle out. So if you've got a beer that's, that was hazy and starts what's called snow globing or getting chunky in the can, that's actually often what's happening is you just have protein particles glomming onto each other, forming a particle that's too big that now precipitates out and isn't staying in suspension in the beer. So that's something to keep in mind is there's a limit to the size of the particles for them to be stable and haze positive. And there are some easy tests you can do. So, on this, obviously, if you want your hazy IPA to be hazy, you probably want some protein haze. But if you want your clear beer to be clear, and it's not, one way that you can test to rule out protein haze is to just add a few drops of, if you're in a professional brewery, a few drops of caustic sodium hydroxide to a glass of beer. And if that clears after 10 to 15 minutes, you're probably dealing with protein haze. And it often does happen like right away too. It's pretty cool to do. And just make sure you don't drink that beer. Just, dump it and rinse the glass. But that's a really nice quick test for protein haze. We also have polyphenol and tannin haze. These can also contribute to or cause haze in beer. Another classic example of polyphenol haze is if you make a batch of iced tea and you cool it down. It might look clear when you first make that batch of tea, but when you cool it down, it turns super hazy. That's tannin haze. So that's a classic example. Most black teas will actually make haze. So if you make a batch of iced tea and you're hoping for it to be crystal clear, you actually have to use a certain type of tea to accomplish that. So that's a really good example of actually just like chill haze as well. These are often more haze forming, haze positive at colder temperatures, which is why they can be a real problem in beer. So this includes a bunch of different compounds, categories of compounds that'll come from plants. So proanthocyanins, catechin, epicatechin, gallocatechin, all the catechins. And in beer, those are going to come from your malt and hops. If you're using other ingredients like tea or fruit, you might also get polyphenols and tannins from those. And these are often the root cause of chill haze. So if you're dealing with a chill haze issue, this is the place to look. And it can even be upstream in grain extraction, right? A lot of different factors in the mash will impact how much polyphenol and tannin is extracted from grains. So it can be a bit of a pain to troubleshoot. But if you're looking to test for polyphenol haze, typically most of these are chill hazes. So you can bring a beer up to room temperature. If it clears up and you don't see a lot of stuff dropping out, it's probably chill haze. And another thing to keep in mind here is that those polyphenols can form stable complexes with proteins. So you can form a protein polyphenol haze. And that is a key part of the haze in New England or hazy IPAs. You can have these tannins or polyphenols complexing with proteins, like we just talked about, and that can be greater than some of its parts in terms of haze and haze stability. So that's a key. It's not the whole story of the haze in hazy IPA, but it's a big part of the story. Another form of haze that isn't too common, but it does come up, we have seen it, is starch haze. So if you have unconverted starches in the wort, in the beer, probably resulting from a hot mash or a short mash or an incomplete mash, that can cause haze in a beer. So there's an easy way to test for that. It's exactly like you would test for starch in your mash. You can add a few drops of iodine to a sample of beer. And if it turns dark, turns blue or black, you know you have starch. The iodine will react with the starch and form that dark color. So that's a good test. It does come up. Sometimes people will experiment with hot and short mashes uh, for whatever reason. Non-alcoholic beers would be one example, and then end up with unforeseen haze. So it's something to keep in mind. Don't rule out the possibility of starch if you're troubleshooting a haze in a beer. And then we get into yeast. So there's a few different types of yeast-dependent haze. So number one we'll talk about is cells in suspension. So if you have yeast that hasn't flocculated, it hasn't settled out in your beer, that can cause noticeable haze. So yeah, you've just got, again, particles in the beer that are scattering light, so it's going to show up as a haze. However, especially when we're talking about a hazy IPA, we typically don't want yeast in suspension or too much yeast in suspension because it's often undesirable from a sensory standpoint and a stability standpoint. It usually doesn't taste that good. It usually isn't very stable either. Like it will eventually drop out. So if you've got a hazy IPA that has a really high amount of hop bite or hop burn, like it has that sort of burning astringency in the finish, one issue might be that you have unflocculated yeast in there as part of the haze because a lot of those like bitter hop compounds will bind with the yeast and take some time to settle out. And then if you also have a beer that's snow globing, like it was hazy and now it's chunky, this can also be an issue where you have yeast in suspension that's probably pretty stressed out, and it might impact some of the other haze forming particles in that beer. So a way to diagnose this is if you have a microscope, and I recommend that anyone brewing has a microscope. You can get some pretty affordable ones. You can just check the beer under the microscope to see if there's a high concentration of yeast in suspension. I would say if you're taking a beer and you're seeing, this much yeast or more, then your beer may be at risk of having a yeast-dependent haze, and it can be much higher potentially as well. What you can also do to further confirm that is that you can try adding some finings that will attract with the yeast. So something like isinglass or gelatin, and you can add that to the beer, let it sit overnight. If you see all that drop out quickly, then it's another indication that you have a yeast-dependent haze. But there are other things that yeast does as well, and we're going to dive into this a little bit more later on. But yeast can also impact haze through some other additional mechanisms that are still poorly understood, although we're learning more. Even without yeast in suspension, some yeast can leave beer hazier than others, and that's a key point. So, I do hear people still talk about using low flocculating yeasts for hazy IPAs. That is absolutely not necessary. You can use a flocculent yeast to make a hazy IPA because some yeasts are haze positive independent of flocculation. They will leave a beer hazier than some other yeasts that we call haze neutral. So that's really important to keep in mind. The haze that we're desiring from a yeast in a hazy IPA isn't typically or ideally a result of that yeast actually still being in the beer. It's just a result of byproducts produced by that yeast. And vice versa, if we have a beer that we want to be clear and it's unexpectedly hazy, that may also be the result of something produced or not produced by the yeast. So it's important to keep in mind that even, regardless of the cells, yeast can have a pretty profound impact on the haziness of a beer. And this also does matter over the course of the fermentation. So one kind of cool thing here is that the pH of the fermentation will actually impact how all of these different haze forming particles, whether it's yeast or protein, will interact. So, one classic example is that at the start of fermentation, yeast, which is a negatively charged particle, and shrub, which at that pH is a mostly negatively charged particle, those will repulse. So you actually will have, yeast not really being able to bind up with shrub. So in that case, it's all just kind of floating around in your beer or wort. But at a certain point, when the fermentation pH drops as a result of the yeast fermentation and growth, some of those particles or proteins in the shrub will reach their isoelectric point, and the charge will actually change. So at that point, the shrub actually can bind to the yeast, because when we're looking at these kinds of electrostatic charges, opposites attract. So yeast will actually bind up with that trub, and that will work together to help settle out both the trub and the yeast. So it's always just something to bring up here is that trub actually can be a positive for clarity in a beer, especially because I do see an increase in the practices of brewers um, focusing on making the clearest wort possible going into fermentation. And sometimes that can work counterintuitively to achieving the clearest beer possible because if you don't have some trub in there, sometimes there's nothing for the yeast to bind to, and it makes it harder for the yeast cells to actually bind up everything and flocculate out and make your beer clear. So, counterintuitively, if you're having haze issues with your beer or flocculation issues with your yeast, and you've recently started tinkering with, whether that's dropping out your trub, cold settling, flotation, there's lots of stuff that people are experimenting with. You may want to strategically introduce a little bit more trub into the beer, and you often might find that you'll get more clarity faster through that practice. Although it may depend on your individual brew house and process. And also just a note on troubleshooting haze, it's complicated. Most or many haze issues are a result of several of these different factors. So I provided some tests that you can use if you're dealing with a haze and you want to know what it is. You can use those tests. However, you often do encounter multiple types. You might have a beer that has a yeast haze plus a chill haze, for example. So that also then means that interventions are a little bit more tricky and troubleshooting is a little bit more tricky. So this is one of the more difficult things to troubleshoot in terms of beer fermentation and beer finishing because haze can attack you from all angles. So it's just something to keep in mind as we dive in further. So how do we mitigate haze? One great approach is findings. Another option is time. Often things will settle out over time. So if you look at super traditional lagering methods, that's what's going on. But we do have some technological solutions, some of which are quite old, that we can use to speed the process along and make your beer clearer. So the key principle here is that ionic charge or electrostatic charge, because when we're looking at that kind of chemistry, opposites attract. If you have a positively charged particle and a negatively charged particle, they are going to attract to each other, bind together. And in a lot of cases, when we're looking at this principle of we have a bunch of particles causing a haze, if those can get bound up, eventually they reach a high enough mass that they will actually settle out, and so you'll drop out that haze. So that's what's going on in general with most findings. So as an example, you can use a positively charged finding like gelatin or isinglass, neither of which is vegan, both of which are incredibly effective at sedimenting negatively charged particles like yeast. So if you have a yeast that's just not flocking, then those are the best findings to use to drop it out. On the other hand, you would use a negatively charged finding like whirlfloc, carrageenan, a lot of those types of products if you're trying to sediment positively charged particles. So your trub protein, for example, polyphenols, tannins, those are what's going to be effective for those. We also do have other findings based on silica or PVPP, which can work in different ways. And it's always good to check, the specs on the individual finding product that you're using to make sure that it's actually appropriate for what type of haze you're trying to drop out. Because if you're trying to drop out yeast with a negatively charged finding that just doesn't act on that type of particle, then you're just going to get frustrated because it's just not going to work. So that's something to keep in mind. There are also, other options. I think I listed some of them below. Bentonite. You can actually use tannins as well to drop out other tannins. So that's also something to keep in mind. Sometimes these things will attract each other. So how do we actually mitigate haze if we're trying to make our beer clear? So with yeast, the root cause is typically bad growth. You don't get enough yeast cell growth, so you don't have enough yeast cells colliding with each other. and that tends to lead to poor flocculation. The root cause of that is often nutrition. The yeast just didn't get enough of what it needed, whether that's fan, magnesium, zinc, oxygen, whatever. Something was missing. However, this can also be an issue with just using a poorly flocculent yeasts. Some yeast strains are just not very flocculent, so that will mean that this is more of an issue. However, if you want to ensure the most success for yeast flocculation, you want to make sure your yeast has enough of its micronutrients, especially magnesium and zinc. Both of those are important cofactors for yeast growth and flocculation. Calcium is important too, obviously, with flocculation. And you also want to make sure that, in general, a good solution is to provide yeast nutrition. A yeast nutrient is going to help ensure that the yeast has the baseline that it needs for flocculation and growth. However, if you do have a yeast that's not flocking out, there are post-fermentation findings like gelatin or isinglass that you can use. With protein haze, the root cause is typically too much trub. You don't have enough kettle findings. You didn't have enough sedimentation in your whirlpool, which meant that you have way too much trub or protein in the beer. That's typically the issue. So in that case, really you're looking at upstream process in the brew house, using kettle findings or adjusting, how you whirlpool or transfer that wort. I would also avoid, having a wort that is too devoid of protein, because you do need some in there for yeast nutrition and for yeast flocculation later on. One thing to watch out for is the pHs in the brew house as well. And if you do have a protein haze, there are well-established findings that can work here as well for you. So chill haze, which can be a subset of protein haze, but often does also include those polyphenols. Again, that can be a result of insufficient kettle finding or sedimentation. Often it's a result of having too much protein and too much polyphenol in the wort, and it not being precipitated out with the yeast in the fermentation. So both time will settle out chill haze over, if you have your beer cold for long enough. You will drop it out for the most part, but there are also post-fermentation findings that can be effective as well. So you've got some solutions for chill haze. And then with starch, it really is a mashing brewhouse issue. You want to ensure complete starch conversion in the mash. I would always avoid making an overly starchy wort, even if you're doing NA brewing. It's just, a little bit risky in terms of overall beer stability in a lot of ways. So you can make a less fermentable wort without making it super starchy with the right mashing method. Okay, so now we're going to jump over to yeast-dependent haze. I hope this gave a good overview of the different types of haze in beer and how to troubleshoot them, and I hope that's useful information for keeping your clear beers clear and also helping to encourage haze in your hazy beers. And we're going to, because we're the yeast people at Escarpment Labs, we are going to talk a little bit more about yeast-derived haze. So a lot of our historical knowledge on yeast-derived haze is mostly from the wine industry. White wine haze is a problem area for a lot of the same reasons. You don't have a whole lot in there for yeast to stick to and flocculate out, and you also have other stuff that comes off the yeast cell that can cause haze. So this is known in wine that yeast cell wall manoproteins can cause haze. Yeast cell wall chitin, which is another polymer, can cause haze, and yeast protease activity, so yeast secreting enzymes that break down proteins, which we talked about in the nutrition talk, those can also impact haze as well, potentially reduce it. So if we just want to summarize quickly, yeast is a double-edged sword with haze. It has haze-positive factors and haze-negative factors. And the degree of haze-positive and haze-negative factors, both in the yeast strain that you're using, as well as in the actual fermentation environment, is going to impact whether you have a promotion of haze or a removal of haze. So with haze-positive factors, it's known that yeast manoproteins can stabilize haze. And there's some new research on yeast manoproteins in beer as well, which is really cool. and possibly some other yeast proteins as well, but this is still poorly understood. In terms of haze negative factors, we know that yeast can secrete proteases. Those are enzymes. They break down proteins. Often, when the yeast is stressed and needs some amino acids, they will secrete these proteases, which will break down some of those proteins. And if you're trying to achieve a protein polyphenol haze, like a dry hopped hazy IPA, you don't want these. These are going to break that haze down and cause it to either turn clear or turn chunky. And then also, confusingly, some yeast manoproteins can also destabilize haze, so it doesn't always promote it. So this is just an illustration of what factors might actually be influencing haze in yeast, and this is still poorly understood. But in general, a lot of this comes down to the cell surface. So a lot of the stuff that's most exposed to the environment, like the nanoproteins right there on the outer edge of the yeast cell wall, or flocculins are another example. So that the proteins that help yeast to flocculate are also related. To some of these proteins that can impact the haze of a wine or a beer. So it's kind of cool. And also some of these other things like chitin and beta glucans. So these can either be sheared off of the yeast cell wall or just interact with other things, other particles in the beer to impact haze. It's still poorly understood, unfortunately. But there has been some research, which is really good to see. So there's been some great work done by the hop companies, including John Paul May at Hopsteiner. I think this was a landmark paper, The Hidden Secrets of the New England IPA, where they really dug into, what's actually going on. At that time, 2018 was when the hazy IPA was really taking off. So it's very timely research. And what they found was that New England IPA or hazy IPA haze is a protein and polyphenol haze. And what it can do is it can also bind to other things and act as a carrier for those. So whether that's for flavor or whether that's for, other functions, that haze is relatively stable and typically consists of a lot of protein, proline-rich protein and polyphenol. So that was great, although we didn't, fully understand other contributions like yeast. There's also a really cool pair of papers came out in 2021 that really detailed an issue in a brewery that had unfilterable haze. And what those papers identified was that proteins in the yeast membrane were actually showing up in that unfilterable haze. So it was one of the first pieces of evidence that yeast proteins can actually directly impact haze in beer. In fact, the hazy samples had more yeast proteins in them than the non-hazy samples, although they did not find a cause. They didn't find a smoking gun. They just said, okay, there's yeast proteins that are impacting this. It's still very, very cool, showing some impact of yeast-dependent haze that isn't dependent on flocculation of the yeast. And that brings us to some of the work from, this is from Omega Yeast. So they've been doing some really, really cool work. We did some collaborative work early on and a CBC talk. And they took it a step further and really found some answers here. So I'm not gonna dig into it too much because I'm pretty sure they have a talk on their own paper, but it's really cool and really worth highlighting. So what they found was that there's a gene, a manoprotein, so one of those proteins that's sitting right on the edge of the yeast cell wall, that they call hazy-1. And in this gene, some yeasts that are haze positive, so some yeasts that form more haze in a beer than others, even when the yeast is removed, have an expansion in this gene. So the example that they use is the 011 strain, which for reference is similar to our Foggy London strain at Escarpment Labs, which is known to be the most haze-positive yeast. And it also just so happens to have one of the biggest expansions in this gene. So one thing that's known is that expansion, or basically increase of size added of repeated regions in these genes, can impact their function. In other manoproteins, it can change how the cells are buoyant, so it can make a yeast more top cropping than other yeasts. it can do all sorts of interesting things. You can also change flocculation behavior. It really is one way that beer yeasts seem to like to evolve to modify how they respond to their environment, how they respond to how we use them as brewers. So it's kind of to me like a byproduct of that yeast responding to whatever it is we're asking them to do. But at the end of the day, it's really cool because this is an actual functional explanation for why some yeasts make more haze than others, which is really, really useful because we didn't really understand it very well before this. We just knew some yeasts are haze positive and some yeasts don't really have an impact on the haziness of a beer. However, they did show for some of those strains that having that expansion, which here's the N-terminal length, of that gene made the yeast haze positive, but that's not true for all of the yeasts. So one of our challenges here across the board is that beer yeasts are very complex genetically. There's a lot going on, so that might mean that there's not a simple explanation for some of the things that we're trying to explain with brewing yeast so that we can make it easy to use them and get the results we want. So there's still more to learn, right? This gene seems to be really, really important in this yeast, especially like the Foggy London type yeast, but it might not be the only explanation for haze control in brewing yeasts. And I just wanted to sort of illustrate some of the differences here too. Like, what is the actual functional difference in haze between like a haze positive and a haze neutral strain? It's like it is significant, but it may not be huge. You will notice it a lot more in a heavily hopped beer, but I just thought I would pull this out to show, like, in a regular blonde ale wort, what is the difference? So this was basically beer that was fermented 7 days and then cold crashed another 7 days and then visualized with a flashlight with a red sticker on it on the other side. So you can actually see Cali-Ale on the left-hand side there is haze neutral. You can see the sticker. This is kind of our low-cost turbidity test, although there is a local brewery with a turbidity meter that we can use as well, which is nice to have. We don't have one ourselves. And then you can also see some examples of haze-positive strains. So that haze, that is not yeast cells. If you take that beer and you put it under the microscope, you do not see any yeast cells. They've all flocculated out, but there is still haze left behind by the yeast, as opposed to the haze neutral strain like California Ale and vast majority of lager yeasts are haze neutral. They won't really impact this, whereas some of these other yeasts, Foggy London Ale is the classic example. It's almost always the most hazy, and that's part of why people love this type of strain. It just makes it really easy to make a hazy IPA. And then there's new strains as well, like Pomona, and we've got another experimental coming that's also haze positive. So if you're looking to select a haze positive yeast for your hazy IPAs, the yeast does make a difference. Some yeasts will make it easier to achieve a stable haze. Some will make it more difficult. So you do have some options. The classic go-to is the Foggy London Ale. It works. It's super reliable. And there are new options as well. So Pomona, which was released this year, it's a new hybrid yeast hybrid of two of our strains to make one single new strain. We put it through the lab evolution process, and weirdly enough, that process actually made the strain more haze positive. So like I talked about, the yeast is always trying to evolve in response to its environment. And one of the ways that it likes to do that is to, have expansions or contractions in some of these cell surface genes. So what probably happened with this one is that it might have had some expansion in that hazy 1 gene. We haven't had a chance to go and look, but that certainly is possible. That does happen even just with repitching. So that's another thing to keep in mind. Repitching yeast may change its haze behavior, both positive or negative. So that's something to watch out for. But long story short there, Pomona is another option for haze positive yeast. A little bit more attenuation than the Foggy London Ale, certainly more ester production, really nice peach ester. If you like the Vermont strain, but you don't like that it's haze neutral, definitely try out Pomona. It's basically, that's what it was developed for. And then also Hydra. Hydra's been out for a few years now, but it's become consistently popular. It's a great low attenuation strain for juicy, hazy IPAs, and it is also haze positive. So it does make it easier to produce those hazy IPAs. Another thing I want to touch on, because we've always got to work in a pitch for yeast lightning in here, is yeast management does have an impact on haze. Poor yeast health will lead to haze-related issues on both sides. Poor yeast health can make your hazy beers clear, and it can make your clear beers hazy. If you're trying to promote the protein and polyphenol haze in a hazy IPA, stressed yeast will break down those proteins, and it will ruin your haze. So you need to make sure that your yeast is well fed and happy. If you're trying to prevent haze in your clear lager or Kolsch, bad nutrition will cause the yeast to fail to grow and flocculate properly. It may also impact the ability of that yeast to sediment with some of the other haze-forming particles in the beer, like the proteins and tannins, and can result in a beer that's hazier than it otherwise would be, which would then require more finings, more filtration, just more work. So you have some upstream solutions in yeast nutrition, making sure the yeast has enough vitamins, minerals like zinc, all can really, really help to make sure that that yeast is happy and healthy and producing the beer that you expect. And, we actually have had several brewers who were struggling with haze stability off and on report success with managing their targets using yeast lightning. So there are some really cool success stories out there. And that's it for today. This one's a little bit shorter than usual. There's lots of other information out there on hop-derived haze. I didn't want to go into too much depth because there's some awesome resources. But if you do want to dive into it more on the yeast side and troubleshooting side, we do have a pretty thorough article on troubleshooting haze on our knowledge base. So make sure to check that out. A lot of this content was pulled from there. You can check us out on YouTube. I hope you're watching along on YouTube. We release every single webinar on YouTube, and we also have some other material on there. And also make sure to check out our blog. We're going to have some more stuff coming out before the end of the year for you to read and check out, including our predictions for what we think is going to happen in beer in 2024. And it's not all doom and gloom. I think there's some really cool things to be excited about. So that's it for this talk. As always, stick around. I will stick around for some Q&A. You can always scan the QR code to access our educational resources. And I look forward to seeing you next week, where we're going to be talking about the modern IPA. This is a talk that's going to wrap up a lot of the things we've been talking about in this webinar series into some practical suggestions for where we think the modern IPA is going, because even if you hate hoppy beers, they're not going anywhere. They are the dominant craft beer. And I think there's a lot of cool opportunities to continue to innovate and improve upon the IPA. So we're going to talk about that. All of this stuff around controlling haze, around controlling flavor, around nutrition, everything. We're going to try to put it all together so that you can make a better IPA. And stay tuned as well. Wrapping up this series, we're going to be releasing some videos over the Christmas break on YouTube on lager production. So if you were intrigued about some of the conversations on lager production, some of the things that I brought up today, there's going to be a much deeper dive that's released for you to watch over the holidays as well. So hope you have a good holiday break as well. I will see you next week, and we're going to talk about IPA and wrap things up. Thanks for checking us out live if you're here live. Thanks for watching us and making it all the way to the end on YouTube. If you're watching on YouTube, really appreciate the support, and we're going to dive into some questions. So I have a question from Laurent. To what extent does centrifugation impact each type of haze? Okay. My worry is that behind that, would centrifugation be able to correct an excessive haze to reach the brand target and still have a stable haze? Centrifugation is cool. And if you have a centrifuge, it can help you solve a lot of problems. So like one example is you can absolutely pull out yeast, like unflocculated yeast with a centrifuge, because those particles are going to be bigger and heavier than the like haze particles in a hazy IPA. So typically breweries who have centrifuges can dial them in so that they're able to fuge out the yeast but not fuge out the haze. Or they may some centrifuges you can even set the output turbidity. Some of them have turbidity meters on them, which is another awesome way to basically dial in your haze. So if you have a centrifuge, it's an incredible tool for achieving consistency with haze. So I got another question. Are there any lager strains that are haze positive? I don't know. To our knowledge, so far, most of the lager strains are haze neutral. So I mean, you can still make a hazy beer with a haze neutral yeast. That is really important. You know, all of these other factors like the proteins and polyphenols, tannins, those will, you know, you don't need yeast to achieve a stable haze, but yeast that is expressing some of these haze forming proteins will make it easier. So that's just something to keep in mind. I don't see any other questions. So I think what we're going to do is we're going to sign off for today. So again, thank you for tuning in live. Thank you for signing up.